Hello everyone, hope you are doing well. Next three videos, I will explain about Java JVM architecture. In this video, I will explain about Java JVM high-level architecture. Second video, I will explain about Java JVM low-level architecture. Third video, I will explain about Java JVM complete architecture. So JVM stands for Java Virtual Machine. It contains three parts: various memory areas, class loader subsystem, and execution engine. So let's get started. For bullet points, I am open notepad, JVM theory. For diagrammatic representation, I am open this. First, I will start with JDK. Suppose assume this is a JDK. So let's go to node points. First point, JDK stands for Java Development Kit. Java Development Kit. It contains R library files and utilities to develop Java programs. So JVM theory, first point, JDK stands for Java Development Kit. It contains library files and utilities to develop Java program. So second point, so suppose assume this is a rectangle is a JDK. Assume this is a JDK. JDK stands for Java Development Kit. It contains R library files and utilities to develop Java programs. Right? So JVM. JVM stands for Java Virtual Machine. Java Virtual Machine, and JVM is part of JDK. JVM is part of JDK. So this is JDK, right? JDK inside JVM is there. JVM, Java Virtual Machine, right? So third point. So now I will create one Java program. For that, I'm creating one folder, JVM, suppose some folder like this. I'm creating one class, Java class, maximize public static void main string args. This is the method. Before method, we need to add class, public class, first letter capital demo. This is a class, first letter is capital. This is a class name, first letter capital. Some message, system.out.println, suppose hello. So this is a public class, so we need to save with class name, same class name. File save as .java. So I am closing here. Now we have demo.java, right? So I am opening CMD. So the JDK, this is JDK there, right? The JDK path I am configured in environmental variables. So anywhere in this system, I am configured into system variables, Java home, JDK I am configured in the system variables. That means anywhere in system, I can able to access it. Remember this. So that's why I'm accessing here. Let's check Java version, Java version 17 is there, CLS. So Java C means compiler, Java C space class name dot Java. Observe here, demo dot Java file is there. I am compiling now. See, compiling now. See, demo dot class file created. After compiling, demo dot class file created. So next point, third point, create one Java file. Create one Java file and compile it. Observe one dot class file will be generated. So here one dot class file generated, right? So after that you can run Java space class name demo, no extension, enter. So we are getting output, right? So node point, port point, run or execute dot class file, dot class file, dot class file. JVM starts from here. So example Java space demo. When we are executing or running dot class file, JVM execution will be started. Remember this point. Whenever we are running or executing dot class file, then JVM starts from here. JVM starts from here. So then one JVM box I will draw. Yeah, suppose this is JVM, Java Virtual Machine. Java Virtual, Java Virtual Machine. It is a JVM. So here where Java C demo.java demo.java. So first we are created demo.java file. After that we are compiled. After compilation, we got the dot class file. So here after compilation, we got the controllers I am saving temporary. So after compilation, we got the demo.class file, demo.class. So after getting demo.class file, we are executed. So Java space demo controllers JVM starts from here. So when we are running Java space demo comment JVM starts here. So JVM starts here. Right? JVM starts here. This box will be created. After that fifth point JVM will be created with various runtime areas. That means so here one box will be created. Suppose assume this is a various memory areas. Various memory areas. This box will be created. So this box contains 5 parts. 1, 2, 3, 4, and 5. 5 parts. This is a method area. It is a method area. Second, heap area. Heap area. Third one, Java stacks. Fourth one, PC registers. Fifth one, negative method stacks. Negative method stacks. Yeah. So when we are running Java space class name JVM starts from where JVM will be started. So after that, various memory areas will be created. So these various memory areas are 5 parts: method area, heap area, Java stacks, PC registers, native method stacks. So note point, fifth point, JVM will be JVM will be created with created will be created with various runtime areas. Here in diagram, JVM starts from where JVM starts created, same like JVM will be started. So you can mention JVM will be created or started. JVM will be created or started with areas, runtime areas. These are the 5, right? We are said 5. They are 5. They are 5. One is method area. Here in method area. Second one, heap area. Third one, Java stacks. Fourth one, PC registers. PC registers. PC stands for program counter. PC stands for program counter. Fifth point, native method stacks. Sixth point is here JVM will be starts or create with various runtime areas. They are method area, heap area, Java stacks, PC registers. PC stands for program counter. Native method stacks. After that, JVM first will search for .class file in method area. So what will happen here? The JVM will search .class file in method area. First JVM will search .class file in method area. First it will search .class file in method area. Will search .class file in method area. Remember this point. So it will search JVM will search .class file. So JVM control Z here. JVM will search for .class file in .class file. JVM will search .class file in method area. It will search in method area. It will search node point. 6 point. JVM post JVM post will search. JVM post will searches for .class file in method area. If not found, then request going to ClassLoaderSubSystem. So here I am removing this part. Control Z. Post JVM searches .class file for method area. Control M. See here this node point, 6 point. JVM post will searches for .class file in method area. If not found, then request going to ClassLoaderSubSystem. So JVM will search .class file in method area. This .class file loaded into method area or not. Method area .class file. This demo.class file, it is available or not. JVM it will search as. If not available, then request going to class loader subsystem. Assume like it is a class loader subsystem. So class loader subsystem request going to class loader subsystem. This is a class loader subsystem. Move to above. This is a class loader subsystem. Then class loader subsystem searches for dot class file in various locations. If found, dot class file, then loaded into method area. Else, class loader subsystem will throw ClassNotFoundException. Like that means, so whenever we are starting java.demo, JVM starts from where after starting for this dot class file, demo.class file, searches in method area. It is already available in method area or not, JVM will search it. If not available, request goes to, then request goes to a class loader subsystem. Class loader subsystem. Class loader subsystem will, then class loader subsystem searches for dot class file in various locations. So what will do? It will go to locations, different locations, like 3 different locations are there. Application like different class loaders are there. 3 different class loaders are there. It will goes to one by one. It will searches in any place demo.class file is available or not. If available, it will load it into method area. So it will searches. So J1 starts from here. What it will do? It searches for dot class file. It will searches for dot class file. So if not found, it will goes to request class loader subsystem. If not found, it will goes to class loader subsystem. Then class loader subsystem searches dot class file in different class loader subsystems. So J1 starts in method area, searches for dot class file. If found, okay. If found, okay. If not found, it will goes to class loader subsystem. Subsystem method area will request to class loader subsystem to search for the dot class file. Then class loader subsystem searches for dot class file in various locations. If found, dot class file then loaded into method area. If found, then loaded into method area. So if found, loaded into method area. Yes, it will throw the class not found exception. It will searches for the dot class file, right? Suppose if not found, then class loader subsystem searches for dot class file. If found, again, if found, it will be loaded. If found, here, JVM starts from here. So whenever we are using java.demo command, JVM starts from here. After that, dot class file searches first. JVM will searches for dot class file in method area. It is already loaded or not. If not loaded, request go into class loader subsystem to search dot class file. So then class loader subsystem searches for the dot class file in various locations. If dot class file found, then it will be loaded. If dot class file found, then it will be loaded into method area. If not found, then class loader will throw. If not found, if dot class file not found, then JVM will throw class not found exception. So here 7 point is then JVM post will searches for dot class file in method area. If not found, then request going to class loader subsystem. Class loader subsystem work here searches for the dot class file and loaded into method area. Remember. Then class loader subsystem searches for dot class file. dot class file in various locations if found dot class file then loaded into method area else class loader subsystem will throw class loader subsystem will throw class not found exception JVM post will suggest for dot class file in method area this area JVM searches for dot class file. If found, okay. If not found, then request going to ClassLoader subsystem. Here, JVM first will searches for dot class file in method area. If not found, then request going to ClassLoader subsystem. ClassLoader subsystem work is searches for then ClassLoader subsystem searches for dot class file in areas locations. If found dot class file, if found, then dot class file. If found dot class file, then loaded into method area as class loader subsystem will throw class not found exception. After that, so class loader subsystem such as for the dot class file, it is found, then it is class loader subsystem is loaded into method area. After that, once dot class file loaded into method area, request going to edge user here 8 point. Once dot class file loaded into once dot class file loaded into method area request going to execution engine 9. So next part assume it is a execution engine. So once successfully loaded dot class file into method area, and after that class members like static method, non-static method, variables, blocks, constructors, these are the different areas will be loaded. After loading completed, this various memory areas work is just loading. Class loader subsystem work is such as for the dot class file, various memory areas work is loading the class in different areas. Execution engine will do here. After that, this is the arrow mark like this. So 9th point, execution engine will execute dot class file line by line and convert into machine code or OS understandable code, machine code or OS understandable code. 10th point, what will do execution engine will execute dot class file line by line. So execution engine will execute dot class file line by line. So dot class file execute dot class file line by line and convert into machine code or OS understandable code. This will do execution engine, it will do. So 10th point is finally observe JVM contains three parts. One is various memory areas what it will do memory areas loads dot class file loads dot various memory areas loads dot class file members like it will also load members like if it is class is loaded class contains loads dot class file members also loaded like members like methods variables blocks etc right. So second part, class loader subsystem such as for dot class file and loads into method area if found loads into method area, else it will throw the class not found exception. Remember this point. Execution engine dot class file executes line by line dot class file executes line by line and converts into OS understandable format is all about JVM high level architecture. I am repeating one more time. See here. So in this video we are discussing about Java JVM high level architecture. JVM contains three parts: memory areas, class loader subsystem, and execution engine. Remember these points. So JDK stands for Java Development Kit. It contains all Java. It contains all library files and utilities to develop Java program. So where one box, this box is a JDK. JDK stands for Java Development Kit. It contains all library files and utilities to develop Java programs. Remember, JVM stands for Java Virtual Machine and JVM is part of JDK. So JVM stands for Java Virtual Machine is part of JDK. So add another mark. So this JVM I am mentioning here. This is the JVM. When this JVM will be started, after that we have created one Java file and compile it. Observe one dot class file will be generated. After that we have created one dot class file and we have compiled and we have observed one dot class file will be created. After that we are executed dot class file. Here JVM will be started. Once JVM started, once JVM will be started, these memory areas are created like method area, heap area, Java stacks, PC registers, native method stacks. So JVM first will search for dot class file in method area. If not found, then request going to ClassLoaderSubSystem. Then ClassLoaderSubSystem searches for dot class file in various locations. If found, dot class file, then loaded into method area. Else ClassLoaderSubSystem will throw ClassNotFoundException. Once dot class file loaded into method area, request going to execution engine. Execution engine will execute dot class file line by line and convert into machine code or OS understandable code. Finally, observe JVM contains three parts: various memory areas. These memory areas work is loads dot class file. Members also loads like methods, variables, blocks, etc. This memory areas work is to load dot class file. Dot class file contains methods, loads dot class file. So loads dot class file contains methods, variables, blocks, etc. After the class loader subsystem. This class loader subsystem work is suggest for dot class file. If found, suggest for dot class file. If found, loaded into method area. Else throws class not found else throws ClassNotFoundException. Execution engine executes dot class file line by line and converts into YS understandable format. I will repeat one more time through diagrammatic representation. So here, this is the high level JVM architecture. So JDK stands for Java Development Kit. It contains all library files and utilities to develop Java program. So JVM stands for Java Virtual Machine. It is a part of JDK. So JDK contains the JVM. This is the JVM architecture. So first we created demo.java file. After that we are compiled, and after compilation, so we are compiled JavaC demo.java. Once compilation done, one dot class file will be generated. By using this dot class file, we are executing the Java program. So once we are started executing the Java program, JVM starts from here. Once we are run Java space demo command, JVM starts here. Then it will be created one box kind of. This is the JVM will be created. The JVM created. After that, various memory areas will be created. So first JVM will such as dot class file in method area. If found, and it will be already loaded, then it will be goes to execution engine and executes dot class file by line and convert into machine code. Suppose if not found dot class file in method area, then request go to ClassLoaderSubSystem to search dot class file. So then ClassLoaderSubSystem will search for dot class file in areas such as in different class loaders. Like different class loaders are there. I will explain in next video, like application class loader, platform class loader. These kind of some 3 class loaders are there, such as for the dot class file. If found, it will be loaded. If dot class file not found, then ClassLoaderSubSystem will reject ClassNotFoundException. So suppose if found dot class file, then load it into method area. After that, request go into execution engine. Executes dot class file line by line and convert into machine code. Thank you for watching. Next video I will upload soon.